Just when you think you have a handle on our cosmic neighborhood, the universe throws a curveball. On October 9, 2025, humanity's map of the cosmos was redrawn. The announcement from NASA was a cosmic wake-up call. Imagine discovering a massive hidden room in your house. The news rippled through the scientific community. It's moments like these that unite us. This silent giant has injected mystery and wonder into our solar system. So, what exactly did NASA announce? They revealed the confirmation of a previously unknown object, a behemoth of staggering proportions, located in the Oort cloud at the far-flung edge of our solar system. The object has been provisionally named Ethel, an Old English word meaning noble or ancestral. Ethel is a giant with a diameter roughly 4 times the size of Earth. An object with a volume 64 times that of our own planet has been hiding in our cosmic backyard, undetected, until now. NASA was careful in its press conference, emphasizing that we know very little for sure. Ethel is dark, incredibly dark, reflecting almost no light, absorbing more than 99% of the starlight that falls on it. It's like trying to spot a piece of coal in the dead of night from miles away. The object is also cold, barely warmer than the absolute zero of deep space. Its orbit is highly unusual, a long, slow journey that takes it far beyond the plane where our planets orbit the Sun. The announcement was the culmination of years of patient observation and data analysis. Faint, inexplicable gravitational tugs on distant comets and probes like Voyager 1 were the first clues. These were tiny anomalies, whispers in the data that something big was out there, pulling on the fabric of space-time. The object, Ethel, is not a planet in the classical sense. It doesn't orbit in the same neat, flat disk as Earth, Mars, or Jupiter. It exists in a category all its own, a new class of celestial object that we are just beginning to define. Finding Ethel was a masterclass in cosmic detective work. You can't just point a telescope and find something that absorbs nearly all light. The search began with gravity. For years, astronomers noticed that the orbits of certain long-period comets were slightly off. Their paths were being subtly warped by something unseen. The first major breakthrough came from the Vera C. Rubin Observatory in Chile. Its powerful instruments are sensitive enough to detect incredibly faint changes. While looking for distant supernovae, the observatory's automated systems flagged a series of coordinated occultations. Once the Rubin Observatory provided a target area, other instruments were brought to bear. The James Webb Space Telescope, with its incredible sensitivity to infrared light, was pointed toward the suspected location. This multi-pronged approach, combining gravitational analysis, optical surveys, and infrared observation, was crucial. To grasp Ethel's significance, compare it to what we know. With a diameter 4 times Earth's, it's a true giant, smaller than Jupiter, but far larger than any rocky planet. Ethel is a mega-Earth or mini-Neptune, made of something dense and dark. Pluto's diameter is less than a fifth of Ethel's. Ethel reflects less than 1% of sunlight, darker than coal, a true cosmic enigma. So, what makes Ethel so profoundly weird? It's a combination of its size, location, and composition, all of which defy our current models of how solar systems are built. Our theories suggest that, out in the frigid outer reaches of a solar system, you get two kinds of things: small, icy bodies like comets, or massive gas giants like Jupiter. But Ethel fits into neither category. It's a solid, rocky, or metallic object of immense size. Its orbit is another piece of the puzzle that just doesn't quite fit. Ethel travels on a highly elliptical and inclined path. This suggests it wasn't formed along with the rest of our solar system's family. Then there's the mystery of its profound darkness. Why does it absorb so much light? The very existence of such a massive body in such a stable, distant orbit is a major headache for planetary scientists. With a mystery this big, the scientific community has become a hotbed of theories. One of the leading ideas is that Ethel is a primordial planetary core. In the early days of our solar system, many planetary embryos, or protoplanets, were likely formed. Ethel could be one of these lost siblings, a failed planet whose growth was stunted before it could gather a gassy atmosphere. Another compelling theory is that Ethel is not from our solar system at all. It could be a rogue planet. It then wandered the galaxy for billions of years as a dark, cold orphan before drifting close enough to our sun to be captured by its gravity. A more exotic possibility is that Ethel is composed of something other than normal matter. Finally, there's the Planet 9 connection. For years, astronomers have predicted the existence of a large distant planet. The gravitational evidence for Planet 9 matches the location and estimated mass of Ethel remarkably well. A discovery like this might seem abstract, but it matters to everyone, right here on Earth. First and foremost, it fuels our collective sense of wonder and curiosity. It's a powerful reminder that there are still grand mysteries to solve and vast frontiers to explore. In a world that can sometimes feel mundane, knowing that a dark giant 4 times the size of Earth is lurking in our own solar system is profoundly exciting. From a practical standpoint, understanding Ethel is crucial for understanding the stability of our solar system. An object with 10 times Earth's mass exerts a significant gravitational pull. It acts as a cosmic shepherd, shaping the paths of comets and asteroids in the outer solar system. By mapping Ethel's orbit and understanding its influence, we can build better models to predict long-term cosmic hazards. Furthermore, studying Ethel could revolutionize our understanding of how planets form. If it's a captured rogue planet, it gives us a sample from another star system without having to travel light years to get there. This discovery also drives technological innovation. To study Ethel, we need more powerful telescopes, more sensitive detectors, and faster spacecraft. The quest to explore the cosmos invariably leads to innovations that improve life on Earth in countless, unexpected ways. At the end of the day, science isn't just about data and equations. It's about a deeply human quest for connection. We look at the stars and we see stories. We see ourselves. The discovery of Ethel is not just an astronomical event, it's a personal one. It changes the story we tell ourselves about our home. For all of human history, our solar system consisted of the sun, the planets we could see, and a faint scattering of comets and asteroids. Now, our family portrait has a new member, a big, dark, mysterious one. It makes our cosmic home feel larger, richer, and more interesting. This discovery reignites the romance of exploration. It gives us a new "Here Be Dragons" on our map, a new destination for our dreams and, eventually, for our probes. This connection is fundamental to who we are. The elements in our bodies, the carbon, the oxygen, the iron, were forged in the hearts of long-dead stars. We are, quite literally, made of stardust. When we study the cosmos, we are studying our own origins. Ethel is a piece of that origin story. Whether it's a lost sibling of Earth or a visitor from another star, it is a part of the same grand cosmic process that ultimately led to us. Learning about it is a form of self-knowledge. The discovery of Ethel is not an end, but a spectacular beginning. The immediate next step for NASA and other space agencies is to observe, observe, observe. The James Webb Space Telescope will dedicate a significant amount of its time to studying Ethel's faint infrared glow. On the ground, radio telescopes like the Atacama Large Millimeter Submillimeter Array, ALMA, will listen for any faint radio emissions from its frigid surface. Meanwhile, theorists and computer modelers will be working overtime, running simulations to test the different origin stories. But the most exciting plan is already on the drawing board: a dedicated robotic mission. NASA's Jet Propulsion Laboratory is designing a concept for a high-speed interceptor probe. This wouldn't be a slow-moving orbiter like Cassini. It would be a fast flyby mission. Its goal would be to get a close-up look at Ethel, to analyze its gravitational field, to sample any dust in its vicinity, and to take the first high-resolution images of this new world. The story of Ethel is just starting, and its next chapters will be written by the robots we send into the great dark unknown.